Hi there, this is MJ on the journey back to Silicon Valley. Today we're going to look at problem 88, how to merge a sorted array. I don't even know where to begin from. It was an incredible time. I picked up a lot working on this problem. But before I get into that, let's stick to the basics and just start from the beginning. What you're seeing on the screen is a detailed article about my entire thought process. It's available on my blog and also on Medium. And as I'm going through the video, I'm going to be reading through this article here. Okay, so the problem description, so you're given two integers, nums1 and nums2. And they're both sorted. And then you're given m and n. So m is the numbers in nums1, and n represents the numbers in nums2. Now bear in mind, m represents the numbers that are to be merged from nums1, and n represents the numbers that are to be merged from nums2. So the problem is asking us to write a function that merges nums1 and nums2. The function is not going to return an array. It's going to insert the values from nums2 into nums1. And nums1 has a length of m plus n. So it has numbers in the beginning, then it has zeros. And that's to accommodate for the whole length that would be needed for the final merge sorted array. Okay, so at first I considered using a nested for loop and then comparing the numbers in nums1 and nums2 and creating a temporary array, and then compare the values in nums1 and nums2 and then push the smaller value to that array. And eventually I would get to an array that has all values from nums1 and nums2. That was my thinking. But then I realized there was a flawed approach on paper, and then I had to actually ditch the idea of creating a temporary array. The next approach I thought of, while still using the nested for loop, is I'm going to compare values in nums1 and nums2 and see if they are smaller than or equal. So I will include equal, because if it's equal also, it will need to be inserted in front of that current element. And basically, to insert it into that next element, I'm inserting it exactly at j plus 1. And I thought that approach would work. So I'll just compare the numbers, and then let's say I'm at 1, and then I have number 2. I'm just going to insert it in front of it. And that was the basic thinking I had. And that turned to be also like completely flawed. And it didn't work, so I had to abandon it. And then I returned to considering a temporary array. And then this time I'm gonna push the smaller number, either the number that's smaller or the number that's equal. And I was thinking I was gonna cover the case where there are duplicates. So I went with that approach. It didn't work either. And so eventually I ended up hacking a solution that passed test case number 1. And that was the only test case it was actually passing. But that made me realize that this entire time, like, all my solutions were test case 1 centric. They were all focused on solving solely test case 1. I was not accounting for the zeros, and my merged output always included them. So what I decided to do instead is clean up nums1 from zeros as it comes into the function before I actually iterate over the array. So I thought of getting rid of the zeros, and then I used JavaScript built-in function slice in order to do that. And the idea is I'll iterate over nums2 and then pick up values from there. And then I'll subtract 1 from any value that I find in nums2. And then if I subtract 1 from it, it will tell me the appropriate index at which to insert it in nums1. Right? So if, let's say, a value from nums2 is 5, 5 minus 1 would be 4. That would give me the appropriate index to insert it in nums1. And the steps went something like this. I think it's better to go over the code here. So I'm creating a temporary array called temp, and then that's where I'm getting rid of the zeros, right? So in that temp, it's gonna go over nums1 and then only return the array without the zeros. And then nums2 is gonna sort the array nums2, which was completely unnecessary and unproductive, but that's something that I'm gonna realize way down the line. So I'm iterating over nums2, and then I'm checking if a current element at nums2 is more than or equal to 1. And the current element, the current element in nums2 is more than or equal to 1, and the current element at nums2 is less than or equal to the length of the temporary array plus 1. Now, why did I use this logic? I actually cannot recall, and I don't remember why I actually had this condition, but it did work. So if this condition is true, then I'm splicing at the current element. The current element in nums2 minus 1, right? And I'm not removing anything from the array. And then this, the second for loop will take a number from nums1 and then assign it. It will assign. No. I'm blanking out here. What it's going to do here, it's going to take the temporary array and then copy it into nums1. Because by this time, the temporary array would have had all the values inserted from nums2. So it's going to copy the temporary array into nums1. And then it just console logs the output, nums1. So finally, this approach actually did work. It had a n of log n complexity because of sorting. And then it has a big O of m memory complexity because the temporary array includes the m length without the zeros from nums1. So it passed all 3 cases on LeetCode, and then I submitted the solution. But unfortunately, it was not accepted because even though it was clearing 3 test cases, right, the solution was only passing 14 out of 59 test cases when it was actually submitted. And at this point, like, I felt just completely hopeless. Like, all the different approaches and solutions I've come up with have taken me 5 days so far. And I'm still refusing to look at a solution online because if I do that, I would be an imposter. And I will not be able to solve this problem or any other. And I'm never going to become a software engineer. So as I sat in this self-doubt and despair, I decided to just go back to the basics and actually look up how to insert an element properly into an array. And I realized, or rather, I was reminded of the fact that you can't just simply insert an element into an array and call it a day. Because every time you do that, you're gonna overwrite another element. And that made total sense. Why, I mean, at least partially, why all my solutions, previous solutions, did not work, because they were all based on that assumption. So as I reread actually the description on LeetCode, an essential piece of information that actually eluded me before is that the zeros that are in nums1, they are to be replaced, not removed. They're actually there to accommodate for the elements that are going to be coming in from nums2. And I also realized that I was so dead set on finding a brute force solution to solve the problem. And I was dead set on actually using a nested for loop to do that. Now, brute force solutions often use nested for loops. And usually that's a quick tell that you're dealing with an n square complexity problem. But perhaps a nested for loop is not even the right brute force approach to solve the problem. And that's when I had the epiphany and the biggest personal takeaway from problem 88 on LeetCode and the 5 days that I've spent on it is that you simply don't know what you don't know. And what I mean by that, this was immediately confirmed the moment I looked up what would be the most optimal solution to actually solve this problem. And after I analyzed the approach that was used, I realized that I simply could not have arrived at the solution on my own because I was completely unfamiliar with the pattern with which a solution can actually be found. And that was such a great relief. Like, how many times have I simply taken the wrong approach or made the wrong assumptions, had the wrong information, or simply didn't know what I didn't know, but walked away from the problem thinking I can't solve it because I simply don't have it in me. Or maybe I'm not meant to be a software engineer. I realized that imposter syndrome is it's simply a byproduct of looking at the problem incorrectly, making the wrong assumption, or simply not knowing what you don't know. And I further discovered that actually studying optimal solutions and their underlying approach is critical to actually developing the necessary pattern recognition and knowledge required to be able to solve problems independently. So the more problems I get exposed to, the more pattern recognition I can develop. The more algorithms and data structures I pick up, the bigger my toolbox gets and my ability to actually draw on it to solve problems on my own. And that was a profound discovery for me personally. And that's gonna really change the way I solve, write, or make videos about a particular problem. Now let's get back to actually the most optimal solution to solve problem 88 on LeetCode. It turns out the best approach to merge two sorted arrays is to use a two-pointer technique. In this case, it's actually going to be a three-pointer technique. So here are the steps. Now the idea is to initialize 3 pointers, P1, P2, and just P. So P1 is going to be set to the last element in array nums1. and P2 is going to be assigned to the last element in nums2. P is going to keep track of the correct index at which to insert elements from nums2. And it's going to be initially set to the end of nums1. Now that's included in the zeros, so it will be at the last element of nums1. Bear in mind, nums1's length is m plus n. So P is going to be assigned to m plus n minus 1. So the last element in nums1, and then P1 will be assigned to the last element before the zeros. So that's the idea basically. And then move them accordingly to achieve the outcome needed. Let's look at the code. It's going to explain it much better. So we're initializing 3 variables, P1, P2, P, and P. And P1 is assigned to m minus 1, which is the last element in nums1. P2 is assigned to n minus 1, which is the last element in P2. And then P is assigned to the last element in nums1 that's included in the zeros. And while P1 and P2 are more than or equal to 0, we're going to check if a number in element nums1 is less than an element in nums2, we're going to assign the element in nums2 to P, and then decrease the P2 pointer by 1 to the left. If the number in nums1 is bigger than nums2, then we will assign the element in nums1 to P and decrease the P1 counter. But in both cases, we will make sure that we decrease the P counter so that we keep track of where to insert our next element. The second for loop covers the case when P2 is still more than or equal to 0. So let's say we've copied values into nums1, but it turns out nums2 still has values. It's still more than or equal to 0. Then we will go ahead and copy the remainder values in nums2 into nums1. And then we will decrease P2 until it becomes 0 or negative. And then we will also decrease the P counter, which is always keeping track of where we're supposed to actually insert our element. And this solution cleared the first 3 cases. And upon submitting it, here are the stats. Now, I was absolutely ecstatic to get to this point and actually finally see an optimal solution that I fully understood, knew how to implement, and that had a big O of m plus n time complexity, and then a constant memory complexity, actually. And it was an amazing feeling. It was an amazing feeling. I've picked up so much working on this problem, but most importantly, I understood so much more about myself and my thinking process as an aspiring software engineer. And I think I will look back at problem 88 and the 5 days that I've spent on it as a turning point that made me change the way I look at problem solving. I really hope this was valuable. If it was, like and subscribe. And then until next time, this is MJ on the journey back to Silicon Valley.